In this video, we will do a consumer's surplus example. So in the example, it says that the price P in dollars for a new VR game console, so VR just means virtual reality, is given by this equation. Okay, so we have this exponential equation involving price and demand, where Q is the number of consoles sold. Calculate the consumer's surplus if the consoles are sold at $500 each, round to 2 decimal places. Okay, so to get us started with this, it may be helpful to remember, well, what is the equation for consumer surplus? So in the last video, we wrote that down at the end. Consumer surplus was this integral of the demand equation, once it's in terms of Q, minus P bar, where P bar is the price of the item, and then Q bar is the demand that corresponds with that price. All right. Okay, so in this question, it tells us what the price of the consoles is to be, $500 each. So that is our value of P bar. P bar is going to be 500. Okay, so for my integral, I'm going to need to figure out what Q bar is, because that's the number I put at the top, my upper limit of integration. Okay, so the way we'll get that is, in my equation here, when I plug in P bar for P, that means Q bar is my value for Q. So what I mean by that is, I just write the equation, minus e to the 0.02, but just change the Q to Q bar, and then over 20,000. Okay, so I know what P bar is. I know P bar is 500. So let's rearrange this equation so that we can solve for Q bar. Alrighty, so what I'm going to do is I'm going to move this negative exponential term to the left. So e to the 0.02 Q bar over 20,000. I'm moving it there to make it positive. And let's subtract 500 over to the right. So 1,000 minus 500, that's 500. Okay, and now I can multiply both sides by that 20,000. And if we do that, we will get e to the 0.02 Q bar equals, and then multiplying 20,000 times 500, we get 10 million. That's a lot of zeros, so I'm going to include some commas so I can see it better. Okay, so at this point, to solve this equation, I'm going to need to use logs. I have e to this power equals 10 million. If I rewrite this as a log equation, I'll get 0.02 Q bar equals ln of 10 million. If you don't quite remember how to do that, how to work with exponential equations like this and put them in log form, I'm going to link a video in our description, in the YouTube description for this one. So be sure to check that out if you need some brush up on that. Okay, and now we're ready to get that Q bar by itself. But one simplification I'm going to make is, if I rewrite that 0.02 as a fraction, it's 1 over 50. So we get 1 over 50 Q bar. And it's 1 over 50 because technically 0.02 is 2 over 100. 2 over 100 Q bar. And 2 over 100 is 1 over 50. So now I'll multiply both sides by that 50 to get Q bar is equal to 50 times ln of 10 million. Okay, a lot of zeros. I'm going to plug this into a calculator. And if we do that, I get 805.90478. I rounded it to 5 decimal places. My general kind of guideline about rounding is, so ultimately I need to round to 2 decimal places at the end. That's what my question asked for. So I would use, if I need to round somewhere before the very end of my question, like I'm not at the end yet, if I need to round before the very end, I would use at least 2 extra decimal places when rounding before the end. And the reason for that is, if I were to only use 2 decimal places now, I have a less accurate answer than if I were to use more decimal places. So if I use a less accurate value now, when I do more computation with it, it may sort of propagate that error and make it worse. Okay, so that's why I want to include extra decimal places so I get a more precise value. And then I'll round it to 2 decimal places at the very end. All right. Okay, so let's give ourselves some more room here. So we are now ready to get that consumer surplus, which we denote as CS. So what is our formula for consumer surplus? It's the integral from 0 to Q bar of our demand in terms of the variable Q minus P bar, the price of the item, dQ. Okay, so we know everything here now. This is 0 to, I know what Q bar is. We just got that it's 805.90478. And then our demand equation was already in terms of Q. Right, if I scroll up, this is already in terms of Q. This whole thing, this is D of Q. If it wasn't in terms of Q, I would need to isolate it to get the Q's on one side and to get P on the other side. So this is P equals D of Q. So we'll see an example in a later video of this section where it's sort of the other way around. Q is on one side, P is on the other side, and I'll need to isolate the P to get a function in terms of Q. All right, so plugging in our equation, which was 1,000 minus, and one thing that's going to help is if I write 1 over 20,000 in front of that exponential, e to the 0.02 Q. Okay, and then I need to do minus P bar. And P bar, that price, the items are priced at 500. Okay. And this is dQ at the end. So we are now ready to do this antiderivative. Okay, so we are ready for the antiderivative, but I can make one simplification first. 1,000 minus 500, we can just simplify that. That is going to be 500. So now when I do the antiderivative of 500, I'll get 500Q. And then after that, I'll have minus 1 over 20,000. And the antiderivative of e to the 0.02Q is 1 over 0.02 times e to the 0.02Q. Awesome. Put parentheses around this, vertical line, 0 and 805.90478. So now it's just plugging in some numbers and subtracting. All right, so when we do this, we just want to be careful about parentheses and negative signs and that whole thing. So first I'll plug in the top number, and I'll get 500 times 805.90478 minus, with the next term, I'll get e to the 0.02 times 805.90478 all over 20,000 times 0.02, and then minus what I get when I plug in 0. So I'm going to put a big old parentheses around everything that I get when I plug in 0, so I don't forget about, distributing this negative sign. Okay, if I plug 0 into the first term, 500 times 0 is just 0. And then into the next term, we'll get minus e to the 0 on top. And e to the 0, that's nice. That's just 1. Over, the denominator is 20,000 times 0.02. And from here, we are ready to plug into a calculator. In doing that, we end up with 377,952. Now we round it to 2 decimal places, 42. And the units here were dollars. And that is my consumer surplus. So conceptually, this value represents, if we consider everyone who purchased this console, this VR game console, it's the extra amount that they collectively got to keep in their pockets because overall, a bunch of them were willing to spend more than the console ended up costing. Alrighty, in terms of our goals for this section, we have finished our first goal, which is talking about how to compute the consumer's willingness to spend and consumer's expenditure, which we talked about in the last video. And then we've talked about how to compute consumer's surplus, which we defined in the last video, but we did an example working it out in this one. So in the next video, we'll talk about what the producer's surplus is.